Welcome back. You like it? You like my border? I tried to Andersonify my setup here a little bit, and it also helps me figure out where the board is and where it isn't, so I don't draw on my wall, which is important. So we are back in section 1-2. This is the back side of the notes, or if you've got just the virtual version, it's the second page of those notes. And it starts out with this table, and you can see in the corner here, it's blank in the notes. So you might just want to take a couple minutes, copy these rules down into your own notes. They will be important for you to know because they are the foundation for which we do pretty much any math with real numbers. So pause the video, copy down the properties here, and come back when you're ready to talk about them. All right, you ready? Now, this looks kind of intimidating, just giving them to you like this, but we're going to explain what each of them mean. Nothing in this table is something you don't already know. You've done these things hundreds, if not thousands of times as you've been in math classes growing up. It's just we're putting names to these things that we're allowed to do with real numbers. So remember in the last video we talked about real numbers and how they're classified in different groups. This explains all the things we can do with real numbers, which is actually pretty neat. It's a good thing that these work the way they do, because if not, there would be chaos everywhere. So let's start talking about these. We'll start at the top here with the closure property. And you'll notice that each of these properties, except for distributive at the bottom, has a separate property for addition and one for multiplication. And it's important that it's addition and multiplication. Notice what's not here. We're not talking about subtraction or division. And that's because these properties don't necessarily apply to subtraction and division like they do addition and multiplication. So keep that in mind as we go. Closure does, I think, work for both of those. But for addition, if we let A, B, and C represent real numbers, so like any number that we know about, any number you can think of, if A, B, and C are three different numbers, then if you add A and B together, you know that the result, the sum, is also a real number. You can't add two numbers together and get something that's not a real number. It can't happen. That's called the closure property of addition. We're just putting a name to something we already knew. Same thing works with multiplication. If you take two numbers and multiply them together, two real numbers, you get a real number as a result. That's the closure property of multiplication. Going down to the commutative property of addition, A plus B is the same thing as B plus A. So when we talked about the order of operations a few videos ago, we've already kind of talked about this. If all you have is addition, it doesn't matter what order you do it in. Notice there is not a commutative property of subtraction because A minus B is usually not the same as B minus A. It doesn't work with subtraction, but it works with addition and multiplication. A times B is the same as B times A. So as long as all you have is addition or all you have is multiplication, you can do it in whatever order you want, right? It's when division and subtraction get involved that you have to worry about the order of the operations. The associative property of addition, if you have three real numbers, A, B, and C, this is saying you add A plus B together first and then add C at the end. This property says you can do it that way, or you can add B and C first and then add A. And those are the same thing, right? Because of order of operations, you would figure out what's in the parentheses first. What the associative property of addition is saying is it doesn't matter which two numbers are in the parentheses. You're going to get the same thing, as long as you have addition everywhere. Or multiplication. You can multiply A times B first and then multiply C, or you can multiply B and C first and then multiply A, and you get the same answer. Again, this doesn't necessarily work for subtraction or division. just addition and multiplication. Next, we have the identity property. The identity property of addition says if you take any number and add 0 to it, you have the original number. And also that that's the same thing as taking 0 plus that number. So we're kind of actually using the commutative property here, but specifically if we add 0, we end up with the number we started with. Okay? That's what makes it the identity property. 0 is the number that when you add it to a number, it does nothing. Okay? So that is the identity property of addition. The identity property of multiplication, the number you multiply to do nothing, essentially, is 1. Any number times 1 is the number you started with, which is the same thing as 1 times that number. So you may sometimes hear that the additive identity, additive meaning addition, and identity being this property, the additive identity is 0. And the multiplicative identity, that's an impressive word, multiplicative being multiplication, identity is 1. That's the number you multiply by to get the same number you started with. Okay? So again, you already knew all these rules. What we're learning now is the names that go with those properties. That's what we're talking about. Next property is inverse. So this is if you have a number, you have to add it to its opposite or inverse value to get 0. Okay? So starting at any number, if you add it to its opposite, you get 0. And again, you could do negative a plus a. So you can flip it around like the commutative property says. So the additive inverse is essentially just putting the opposite sign on the number we start with. That might actually come into play in just a little bit. The additive inverse, whatever number you start with, you just put the opposite sign on it to get 0. For multiplication, the inverse property of multiplication, the number you multiply by to get 1 is actually, if you start with a, it's 1 over a. So instead of, you could actually think of a as a over 1. I could put that number over 1 and it's still just a, right? But if we multiply it by its reciprocal, if we flip it upside down and multiply these two things together, we get 1, which is the multiplicative identity. Okay. Now, this rule or this property does fall apart if a is 0. And the reason why is, if you've never done this before, pull out a calculator. You can use your app on your phone or whatever, and type in like 6 divided by 0 and see what happens. My guess is your calculator is not going to like that very much. So you actually can't divide by 0, it's not allowed. So for this property in particular, since we're putting a on the bottom of a fraction, we make the specification that a is not allowed to be 0 because you're not allowed to divide by 0. Okay. Not a huge deal, but it does come up from time to time. Our last property is the only one in this table that doesn't have separate properties for addition and multiplication because it involves both at the same time. The distributive property. Surely you've distributed something in your prior math courses like Algebra 1, right? If you've got something like b plus c in parentheses and you've got an a outside, the distributive property allows you to take that a times b and then a times c, right? So a times b plus c gives you a times b plus a times c. Okay, and the thing you're multiplying by doesn't have to be on the left. It can be on the right, and it still works the same way. This would be b times a plus c times a. The distributive property works both ways. Why did I just spend about 10 minutes telling you about these properties. It was probably really boring, right? You might be given an example of one of these properties and be asked which property is being illustrated. You need to know what the properties are and when each one is being used. You also need to know how to use the properties. So, for example, if you're given like something like this and asked to simplify, you have to know how the distributive property works, that you can distribute that A to B and C and what that gives you. Right? So, in a minute, when we go through the examples in the rest of the notes, we're going to be utilizing some of these properties in the ways that you can expect. All right, so we've talked about our properties. We've got a few examples left that we need to talk about that use these properties. Starting with example 2. It's asking us to find the additive and multiplicative inverse of 2.5. Okay. Keyword here, inverse. We're going to be using this property here. So this is the one for addition. This is the one for multiplication. So if we want to link how we do this problem to this property, it might help to know what A is, right? Because here A is any real number. But in this problem, we're talking about a specific real number, 2.5. So A is 2.5. So the additive inverse, to find the additive inverse, what we said was, no matter what number we have, we just need to take the opposite sign of that number. The opposite sign. So give number opposite sign. So if our number is 2.5, we give it the opposite sign. The additive inverse is negative 2.5. Negative 2.5. No matter what number I give you, if I ask you for the additive inverse, just give it the opposite sign. Now, it could be a little tricky if your original number was already negative. Well, the additive inverse would just be that number but positive. That's how it works. It's really, it sounds a lot harder than it is, right? It doesn't have to be difficult. The additive inverse, just give the number the opposite sign. Now, for the multiplicative inverse, and I've been teaching this for a while. I'm used to the word multiplicative. It's hard to spell. It's really hard to spell. If you wanted to put just M-U-L-T inverse, I would understand what that meant. Okay, I don't want spelling multiplicative to give you anxiety or anything, right? Don't worry about that. To find that, we're using the multiplication property for inverse, and that is no matter what number we have, we flip it upside down. And if all we have is a number, if A is 2.5, we could put it over 1 and then flip it. So, flip number upside down. This is called the reciprocal. Okay? If we start with A over 1, then 1 over A, just flipping the number upside down, is called the reciprocal. Right? The number that you get when you flip it upside down. You don't have to know that. It's nice. But to find the multiplicative inverse, we just need to flip this upside down. We can't flip the number like this. We have to take 2.5 over 1. Right? Same way we did here. We put it over 1 and then flip it. Bottom goes to top. Top goes to bottom. 1 over 2.5. Okay. I'm okay with this as the answer. That is the multiplicative inverse. However, this is a number, and we should probably figure out what it is. Give you just a sec. So unprofessional. Sorry, I was grabbing a calculator. I'm using my phone to film, or I would just whip out my phone and use the calculator app. 1 divided by 2.5 is 0.4. So you could also call this 0.4. That also works. So, if you write this down in your notes, you'll know forever, given any number, how to find the additive inverse, opposite sign, multiplicative inverse, put it over 1 if it's not already a fraction, flip it upside down. Awesome. Next example. Let us simplify this. You might already know how to do that. If so, go for it. Pause the video, don't let me do it for you. But you can see what we've got in each of these terms. We're going to be doing this. We're going to be distributing the number on the outside into everything. So let's see what that looks like. 3 times 4x. 3 times 4 is 12. So that's 12x. Then we distribute the 3 to the negative 2y. So 3 times negative 2 is negative 6 minus 6 with this y. We're done with this. Now we can move here. Now, it's important if this is a minus 2, when we distribute this number, we are treating it as a negative 2. That's important. So this is negative 2 times 3x. Negative 2 times 3 is minus 6 again, with an x. And then we do negative 2 times positive y. There's no number in front of the y, so we can call it a 1. Negative 2 times 1 is negative 2, or minus 2. And this y. Negative 2y. So, by distributing the 3 into these two things, and the negative 2 into these two things, we get these 4 terms. Are we done? Or is there something we can still do here? We can combine like terms here, just like we did way towards the beginning of the year, right? This has an x, this has a y, an x, and a y. We can put the terms that have x's together. We can put the terms that have y's together. So let's put 12x minus 6x. Okay. If you have 12 x's in your hands and I take 6 of them out, what do you have left? You've got 6 x's. So putting these two together leaves you with 6x. We can also put the y terms together. So we have negative 6y and negative 2y. So we do negative 6 minus 2 more. So if you think of a number line, negative 6 is like down here. You're subtracting 2 more, getting further away from 0. That puts you at negative 8y's, or minus 8y. And I've already used circles and squares, so I'll just underline it to show that that is the answer to that one. Okay? We use the distributive property here, and then we combine like terms to get our answer. Cool. Example 4. We're getting some good practice using these properties. Example 4, you can see in the notes over there. It might be a little small to read. I apologize for that. Audrey with a D, went to a post office and bought 8 stamps at 45 cents each. Oh, this is a word problem. So remember the strategy here. Go slow. Write down important information as you come across it. Draw a picture if it helps. I'm not so sure a picture is going to help here because it's not like we're dealing with any shapes or anything like spatial. So 8 stamps, 45 cents each. She also bought 8 postcard stamps at 32 cents each. So, before I keep reading the problem, I'm like, okay, so she bought 8 stamps that each cost this much, 8 postcard stamps that cost this much. Okay. How much did Audrey spend on stamps in total? Okay, that's not too bad. I don't want you to think of this as like a math problem. I want you to think of it as just like, I don't know, common sense. Say you go to Ricker's and you buy 3 pops that each cost a certain amount and 4 bags of chips that cost a different amount. How do you figure out how much you spent altogether? Well, if 8 stamps cost 45 cents each, how much do those 8 stamps cost together? We would multiply those numbers together, right? Eight times 45 cents. You could add 45 cents together 8 times. This is quicker. And then if you also buy something else, then you would do the same thing here, multiply. But what would you do with these 2 things? You would add, right? You would add. Okay? And it doesn't matter which order you do it in, right? This is kind of like the commutative property. So, we just need to figure out what 8 times 0.45 is and what 8 times 0.32 is. Have I done that? I did not do that. All I have is the answer. And the answer is $6.16. Okay. So, just being a little sneaky, throwing in another word problem in there for you, just to show word problems aren't that bad. Go slow, read it slowly, write down important information, and sometimes your natural instincts might kick in. Wait, I know how to figure that out. We just multiply and then add. Okay, it doesn't have to be a complicated mathematical formula. You can use your common sense sometimes, it'll work for you. One more example. We've got 2 girls here who are trying to simplify the same thing. So the original problem, they're trying to simplify 4 times 14a minus 10b minus 6 times b plus 4a. They're trying to simplify this. And you can see the steps that each of them got to and what they got for answers. They ended up with 2 different things. And it's your job to figure out if either of them are correct. Or maybe neither of them are. So what I would advise you to do, I know this has been a long video and you're probably really tired at this point of listening to me, but you get to do this now. I want you to simplify this. Don't look at what they did. Okay? Not because necessarily they're wrong, but because I don't want you to cheat. Simplify this for yourself. See what you get. If you got something different than Luna or Sophia, figure out where they went wrong. Okay? Just as a key to do this, it's going to be very similar to what we did here. It's just, well, it's pretty much the same. So give it a shot, pause the video, see what you get, see if either or both of them are wrong, and come back when you know. All right, so I'm hoping that you gave this a shot and that you know who's wrong. Luna didn't do too bad, but she made a classic mistake. This is probably the most common mistake in this particular problem that I would ever see. The only thing that's wrong is right there. This plus sign. How do you get these terms? The 56a came from 4 times 14a. Minus 40b is 4 times negative 10b. Negative 6b is negative 6 times b. To get this last term, you multiply negative 6 times 4a. But Luna got positive 24a because she forgot that this negative sign was here. She ignored it or didn't think it mattered. Okay? This negative 6 is being distributed to both. So this should be a minus 24a. So when she combines like terms, these become negative 46b. That's right. But if this is a minus 24a, you're not going to get 80a here. You're actually going to get, what, 32a? Minus 46b. That should be what you get. That's the correct answer. So Luna only messed up right there. Assuming this is the correct answer, I think this is right. If Sophia got this, that means she's wrong too. And she's even more wrong because neither of these terms are correct. But where did the mistake happen? Well, again, 4 times 14a is 56a. That seems right. 4 times negative 10b, that's negative 40b. Good. Negative 6 times b, she got negative 6a. And then negative 6 times 4a, she got minus 24b. So this is not a mistake that you see very often. I don't think it's very natural to do this, but she wrote a and b in the wrong places. She flipped them around. This should be a b, and this should be an a. So all of this is wrong. Okay, so Sophia is also wrong. Neither one of them got it right. Plus their souls. They tried. Okay? Whether you ended up getting the right answer or not, problems like this, where you see how people solve the problem, that can be helpful. It's even easier, I think, than just being given this problem and asked to do it on your own. Because you can take what they've done and look at each step to see whether it's right or wrong. The work's done for you, it just might not be right. So, hopefully, with these examples, it gives a little bit of personality to these properties. Again, you already knew all these things. It's not like you didn't know that you could do this. But now you know it's the commutative property of addition. And now that you've got it in your notes, you have that information forever. As long as you have your notes. So, that is the end of section 1-2. If you look on Canvas, there are problems for this section. You can go ahead and work on those. Let me know if you have any problems as you work through them. I'd like to make sure that if you're trying to get these, that you have all the help that you need. And I guess we will see you next time in the next section. So, have a great day.